Hello student, I am Mrs. Pragati Mahale from IT Department of AISSMS IOIT. We are studying Unit 1 of Theory of Computation, a course from Information Technology 3rd year. Today's our topic is Deterministic Finite Automata, DFA. The word deterministic in DFA refers to the fact that the transition is deterministic. It reads an input string with one symbol at a time. Okay, so it can read only one symbol at a time. The finite automata implies the number of states are finite. Okay, the finite word in this DFA determines it implies that the number of states are finite. There is only one path for the specific input from the current state to the next state. Suppose A is our current state. So there is only one path to the next state B on a given input. Okay. So DFA does not accept null moves and DFA can have multiple final state. So this is what is DFA. Now let us see the definition. The finite automata, it consists of 5 parts. Okay, so first, number 1 is the finite set of states, which is represented by capital Q. The second, a finite set of alphabet, which is represented by the symbol sigma. The initial state, which is represented by Q0, and the set of accepting states or the final state, okay, that is represented by F, and F it is a subset of the finite set of states, that is Q. So we write it as F. This is the subset symbol and F is a subset of Q. The next state function, or it is also called as transition function. The next state depends upon the current state and the current input which is applied in that over that state. So a transition function is a function from Q into sigma, and it leads to the next state Q from the set of Q. So it is represented with a delta. So our DFA, that is deterministic finite automata, can be represented with a tuple such that M is the machine with Q, comma, sigma, comma, delta, comma, Q0, comma, F. So this is the set of all the states. This represents set of all the input. Delta represents the transition function. Q0 represents the start state and F represents the final state. Now let us see the representation of a DFA. A deterministic finite automata, as we have seen, it is represented by the tuple M is equal to Q, sigma, Q0, F and delta, that is a transition function. So a DFA is represented by the state transition diagram. Also it is represented by state transition table, and last the transition function. So what is state transition diagram? It is a directed graph which is associated with the vertices of the graph, corresponds to the state of the finite automata. Let us see this example. So this state transition diagram, it is a directed graph because you can see there are arrows indicating the direction of the input from one state to another state, and on every transition you can see what is the input symbol. So in this directed graph, the start state is represented by this symbol. It is a circle with an arrow. Then you have a final state is represented by the two concentric circle, and the intermediate state, if any, it is represented by simply a circle, a state other than a starting or the final state. So the transition table, it is a tabular representation of the transition function that takes two argument. What are those two argument? Two argument is, one is the state and second is the symbol, okay, and a return value, that is the next state. So I mean two arguments, one is the state and symbol and the next state. The row of transition table corresponds to the state. So in the transition table, this transition table you can see, so here the rows represents the states, whereas the column corresponds to the input symbol. So 0, 1 is the input symbol, and the entries in corresponds to the next state, okay. So we have a start state which is marked with an arrow, and then you can have these entries here in this table which indicates that what is the next state. So for example, the transition here, transition function delta is represented as q into input, means a state input and the input symbol, it leads to the next state. So as you can see here in this transition table, our q0 is my start state, okay. We have that transition diagram we have seen in the previous slide. So here q0 is the final state, so it is indicated by the start, and q0 is the start state which is indicated by the arrow. Then q0 moves to q0 on input 0, that means on the input 0, q0 goes to the same state q0. q0 on input 1 goes to q1. So here I can show a directed graph. q0 on input 1 goes to q1. Similarly, q1 on input 0 goes to the same state, and q1 on input 1 it goes to q0. So this is the equivalent transition diagram. This is the transition table. And last is the transition function, that is the mapping function. It is denoted by the symbol delta. So the transition functions gives the next state depending on the current state and the current input. The transition function returns a state which can be called as the next state. So transition function can be represented with such syntax, where transition function delta consists of a current state, comma, current input symbol which is moving to the next state. So in our transition diagram, we can say delta at q0 state, this is the current state. On receiving input 0, we go to the next state, that is q1. Similarly, delta with q0 as a current state, on the input symbol 1, we go to the next state q1. This is the transition function. Thank you so much.